Hey students, these are the notes for section 10.7, the power theorems, which are the segment theorems with our circles. So the reason they're called the power theorems is we're talking about what's called the power of a point. And the power of a point has something to do with the relationship of the radius and the relationship of a point and the distance from the point to the radius, or excuse me, the distance from the center of the circle to the point. But I mean, we don't need to know why these are called power theorems. It's just when you hear me say power theorem, these are the three power theorems. These are the three power theorems in geometry. And they're all about relating to a point either inside the circle or outside the circle. So you do need to memorize these formulas. So the more you do with them, the more you will remember them. The first one is when we have a chord and a chord. So when we have two, we call this the chord power theorem. When we have two chords, we are if I were to show you these similar triangles in this picture, you would get a better understanding of this. This is the actual formula, and you simply take part times part equals part times part. Now, the way this comes into the picture is because if I were to make a triangle and a triangle, we have similar triangles based on the fact that these two angles are going to be the same because they open up to the same arc. These two angles are the same. So therefore, these two triangles are similar. And in similar triangles, we can make ratios where this piece over this piece equals this piece over this piece. Well, if we cross multiplied, we would get this statement right here. So we kind of skip the step about talking about or similar triangles, and we go straight to just memorizing the formula. So the formula is part times part equals part times part. Okay. So example number one, if AP is 4, and we're going to go ahead and I'm going to use pencil since we have two problems. AP is 4, and PB is 6, and CP is 8, then find PD. Okay, so we're simply going to say X times 8 equals 4 times 6. And it doesn't matter which you write first. It doesn't matter the order that you write these in because multiplication is commutative, and it doesn't matter the order. We're still going to get the same answer. So 8x equals 24, and then x equals 3. Okay, the second problem, if AP is 4 and PB is 9 and CD is 15, so the whole thing is 15, find CP. Okay, so in this problem, we have to do a little bit of configuring. So I'm going to put this was problem A, and I'll do problem B up here. So if the whole thing is 15, and I know this piece is X, I need to get this piece right here. And remember, all we simply do is take the bigger piece, which is 15, and subtract the smaller piece. So this piece right here is represented by 15 minus X. Think about it. If I were to add 15 minus X added to X, it would leave me 15. That's how you can double check to make sure you have it correct. So now we can say 4 times 9 equals 15 times 15 minus x. 4 times 9 is 36. 15 times 15 is 225 minus 15x. And we can subtract 225. So 36 minus 225 is negative 189. And then divide by 15, negative 15 actually. And you get negative 12, you get positive 12.6. And it is okay to have that decimal answer. All right, second power theorem is secant. This is a secant. This is a secant. Remember, this is a secant segment, but we have secant lines that go all the way through. This is a secant segment because we just want to look at this relationship. Okay, so the formula is, now you got to pay attention. I'm going to put, because down here at the bottom we have with letters, I'm going to put the same letters that are down at the bottom. So for this problem, A, B, C, and D. Okay, we do not multiply A times B. Okay, if you look, I have this highlighted piece that covers the whole thing. We have to cover the entire thing, and that would actually be A plus B. So down at the bottom, if it helps you with the formula with the A and the B, you can see that it is right here. The formula says A times A plus B equals C times C plus D. And so anytime you're doing these problems, grab your highlighters and you can highlight the outside piece and know that we are adding those two pieces together, and we are adding these two pieces together to solve the problem. And then, of course, anything can show up with quadratics systems to apply this to honors geometry, just like we've had in all of our other material. Okay, so let's look at problem number 2. It says PQ equals 9. Labeling your problems is a big help on these. QR is 3. TR is 4. What is SR? So I'm going to put an X here. I don't want to put the X out here. I'll put the X here because I will use that formula to get what's out here. So just like I said, use your colors or circle it or something to help you remember that you have to use those outside pieces. So this is going to actually be a 12. There we go. And this is going to be a 4 plus X or X plus 4. What I have circled, I wish I hadn't used pen because now I have to do the other problem over that. But anyways, what I have circled is what you're multiplying together. So for part A, I'm saying 3 times 12 equals 4 times X plus 4. Now, you're like, Ms. Ernsberger, can I go ahead and put 36? Yes, but if you will write it like this, little times big, it will visually remind you that you have to have the same thing on both sides, okay? So 36, 4x plus 16, and we get x equals 5. That is not my answer. My answer for SR will be 5 plus 4, which is 9. Okay? All right. PQ equals 11. I'll write that inside here. And SR equals 12. Man, I really messed this up. Let's see. Let's come over here. PQ equals 11, so that means this piece is 11. SR is 12. That means this out here is 12. TR is 5. So in here, where was TR? TR is this little piece right here. TR is 5, so that is this little piece. And it says find PR. PR, we're trying to find, wait a minute. SR. SR is 12. PR. Oh, sorry. My brain got lost. All right, so now I have made this problem. So I've got this piece here. This is what I'm trying to find. Do I have that set up right? Let's make sure. Make sure I have this right. PQ is 11. SR, which is the whole thing here. SR is 12. That's the big piece out here. TR is 5. That's the little piece here. So I'm multiplying the 5 times the 12, and it says find PR, which is, so we had the 11, and we have the big piece, sorry, which is X. Okay, so my pieces, I need to get this little piece here to be able to work this out, and that's going to be X minus 11. So, and I'm so sorry I wrote on top of the problem. It really, this is why you don't use pen in math. All right, so this little piece right here is X minus 11. Remember, it's big minus little. Okay, so we had, I think I put the 5 on the wrong side. That's why I was messed up over here when I was trying to recreate it. So if I put it over here, I think this was 5, this was 12, and then this is X, and this is 11. Those are the pieces that are in the problem, not the 5 right here. That's what messed me up. So this is X minus 11, and that's what we need to use to solve the problem. Woo, let's get going with that. Okay, so part B is X minus 11 times the big, which is X, equals 5 times 12. X squared minus 11x equals 60. X squared minus 11x minus 60 equals 0. We are going to factor to get our answer. All right, so the numbers that multiply to give me 60 are 4 and 15. There are plenty others, but those are the two that subtract to give me 11. So 4 and 15 give me 60, and if I subtract those, it gives me 11. The 15 would have to be negative, the 4 would be positive. There's your factoring. And you can use we're using the X factor. We're trying to get a negative 60 and add to get a negative 11. Okay, so that does work. And then we get X equals 15, X equals negative 4. We cannot have a negative value, so this cannot equal negative 4, so we're going to throw that answer out, and the answer would be X equals 15. Okay, the point we're going to make is be sure you do this little piece times this big piece, this little piece times this big piece. Okay, the next one is the tangent secant power theorem, and the only difference between this one and the one above it is this is a tangent, and what we do is we use it twice. So that's why we have this segment squared. Okay, so we use it twice. This is going to be the same, the little piece times the big piece. I'm going to use my pencil this time. All right, in this one, RT is 25, so that is going to be out here. Okay, 25. It tells us RS is 5, so that is here. That's the little piece. And then we're going to use QR twice. And it says find QR, so that's going to be X. All right, so this is going to look like part A, X times X, which is X squared, equals 5 times 25. X squared equals 125, and we're not dealing with pi, we're not dealing with decimals, we're going to give radical answers unless it specifically says give a decimal answer. From now on, you give radical answers unless it specifically says give a decimal, okay? And so we're going to take the square root of 125. That is 25 times 5, so that's going to be 5 radical 5. And that's our answer. All right, part B. QR is 6. ST is 9. ST is 9 right here. And find RS, which is X. So out here, I need to add the two pieces together and use X plus 9. Don't be confused about these places where I had to subtract because I was given the big piece and a little piece and I had to subtract because I have to use that little piece. In this case, I was given these two pieces and I have to add them together to use this entire piece right here. So we're going to say 6 times 6. I'm going to write it like that so you can see what we're doing. And x times x plus 9. 36. X squared plus 9x. Subtract the 36 over. And what is that? 3 times 12. So x plus 12, x minus 3. That multiplies to give me negative 36 and adds to give me positive 9. And our two answers are negative 12 and positive 3. And we can't have a negative 12 right here, so that's not going to work. So we only use the positive 3. Down here at the bottom, we do have the theorems again, just in a different view. So you can see that it is this piece and this piece. And then this piece twice. I like doing that. And then over here is the same as what was above. So you want to have this paper out when you're doing your homework. Okay. Would you please find the answer to number 1? Super easy question. We would say 6 times 2 equals 3 times x. I want to show you the similar triangles, just in case you ever forget the formula. By angle, so these two angles are the same, these two angles are the same. By angle, these triangles are similar. And so this piece corresponds to this piece corresponds to this piece. If I get a scale factor, 6 over 3 is 2 to 1, so that would have to be 4 over 2 to make it a scale factor of 2 to 1. That should make sense to you. We're dealing with similar triangles. Okay, question number 2. Go ahead and work this out, please. All right, you should have got x equals 6, so we use this one twice. X times x equals 2. Hopefully you use the 18 and not just 16. And so our answer is x equals 6. All right, number 3, just to remind you, we're using this times this, and this times this, and this is going to be added together to give you x plus 3. Go ahead and find the answer to number 3, please. All right, you should have got x equals 13. By the way, let me show you where the similar triangles are in these pictures. If I were to connect this, okay, because these are tangent, we do have a right angle here. And then let me see. If I do this, because these are tangent, we have a right angle here. So we have right angle, shared angle. So by angle, these two triangles are similar, and we make the parts. So this side is used in both triangles. This is the side of the little triangle. This is the side of the big triangle. So now you can see where those come from. We don't make you draw the triangles and try to figure it out. We have formulas that do that for us. Okay, and then here, let's see, like that, the little triangle and the big triangle. And so it is small triangle over big triangle equals small triangle over big triangle, and you would cross multiply and you would get the same answer. Okay, now bottom question, let's just do this together real quick. So this says tangent segment PT measures 8 centimeters. You guys know this is going to be 90. The radius of the circle is 6. Find the distance from P to this distance from P to the circle. So it wants just this distance. Okay, this is really easy. What kind of triangle is this? Okay, 6, 8. So this piece here is 10. This is the radius of the circle. This is a radius of the circle. So this is 6. So what does x have to be? X has to equal 4. You guys know so much about circles. And I'm really proud of you for as hard as you've worked. Okay, in your assignment, anything goes. Okay, you have your 3 formulas, apply the formulas, and then let the math work out itself. Thank you, students.